All right, so now let's discuss just a couple more things that is useful to know about induction and strong induction. And so the first thing to know is that induction and strong induction are mathematically equivalent. So we're not going to show that, we're not going to really talk about it, it's just useful to know. So they are in fact mathematically equivalent. You can prove one from the other in either case. And so that's just an interesting fact to know and good to think about. Another thing to know is that the conditions for induction are logically distinct. And what do I mean by that? Well, what I mean by that is that, a proof by induction has kind of two broad parts. So there's the base case. The statement is true for some value. And then there's the inductive hypothesis and then the induction step kind of all wrapped into one, which is that if P of K is true, so if the predicate is true for some K value, then we can show that it's true for the K plus first value. And then if both of those are satisfied, then, the statement is true for all natural numbers n. However, it's really important to note that you need both of those in a proof by mathematical induction. And there are cases where you can do like an induction step. You can say, well, if, the statement were true for some base case, then it would be true for, the next case, but it's not true for any base cases. And so then mathematical induction doesn't work. Or we can show, statements that are true for some specific numbers, but then we don't have an induction step. We can't show that it's always true for the next step. And so then again, mathematical induction doesn't work.